Picture this, a time so far into the future, our radiant sun, the very life source of our planet, begins to dim and grow. This beacon of life, warmth and energy that has been at the center of our solar system for billions of years starts to flicker. But why? The answer lies in the life cycle of stars. Just like living organisms, stars have a lifespan. They are born, they live, and inevitably they die. Our sun, a middle-aged star, is no exception. It's currently in a phase known as the main sequence, where it's been happily converting hydrogen into helium for about 5 billion years. But nothing lasts forever. Once the sun exhausts its hydrogen fuel, things will start to change dramatically. The core of the sun will contract under gravity, causing temperatures and pressures to rise. This intense heat and pressure will cause the hydrogen in the sun's outer layers to begin fusion, marking the beginning of the sun's evolution into a red giant. The sun will expand, its outer layers stretching out into the cosmos. As the sun grows, it will engulf the inner planets, Mercury and Venus, in its fiery embrace. The Earth, our home, might also meet the same fate. It's a fiery end, a cosmic cataclysm that will render our planet uninhabitable. The sun's expansion into a red giant will be a slow process, taking place over millions of years. But for a star, this is merely the blink of an eye. The sun, once a nurturing mother, will turn into a monstrous beast, its heat and light now a destructive force. And just like that, our sun, once a beacon of life, becomes a harbinger of destruction. In its death throes, the sun doesn't go silently into the night. No, our sun, that beacon of life and warmth, will meet its end with a grandiose exit, a cosmic spectacle that will be both terrifying and awe-inspiring. As it exhausts its nuclear fuel, our sun will begin a process of transformation that will eventually result in its demise. This sequence of events will see our star swell into a red giant, its outer layers expanding beyond the orbits of the inner planets. Imagine a celestial body so large that its outermost layers reach out and swallow Mercury, Venus, and potentially even our home, Earth. But this is just the beginning of the end. As the sun continues to expand, it will lose hold of its outer layers. These layers, full of the elements forged in the heart of the sun, will be released into space, creating a beautiful and eerie spectacle known as a planetary nebula, a cosmic butterfly spreading its wings across the universe. The sun's core, once the powerhouse of its nuclear fusion, will remain. This core will cool and shrink, becoming a white dwarf, a star no larger than our Earth, but with a density so great that a teaspoon of its material would weigh as much as an elephant. This white dwarf will glow with residual heat for billions of years, a haunting reminder of the sun that once was. Now, what does this mean for life on Earth? Simply put, it spells the end. As the sun transforms into a red giant, Earth will become uninhabitable. The oceans will boil away, the atmosphere will be stripped off, and any life that remains will be scorched by the sun's intense heat. And after the sun has shed its outer layers and shrunk to a white dwarf, Earth, if it survives the sun's red giant phase, will be left a barren, frozen wasteland. No longer warmed by the sun, our planet will be a cold, lifeless rock floating aimlessly in the vastness of space. A once vibrant world, now a cold, lifeless rock floating in the infinite void. But fear not, for humanity is nothing if not resilient. As we look to the future, we must consider the possibilities that lie beyond the familiar boundaries of our solar system. Just as the mariners of old charted new courses across unexplored seas, so must we set our sights on the celestial oceans that stretch out before us. Our first port of call in this cosmic voyage? The concept of habitable zones around other stars, known fondly as Goldilocks zones. These are areas neither too hot nor too cold, where the conditions might be just right for water to exist in its liquid form, and by extension potentially support life as we know it. Consider Proxima Centauri b, the closest known exoplanet to us, orbiting within the habitable zone of its star, Proxima Centauri. Despite being a little more massive than Earth, it could provide the right conditions for us to call home. It's a tantalizing prospect, isn't it? A new Earth, just over 4 light-years away, but why stop there? There's a whole galaxy of potential homes awaiting us. Take Kepler 442b, for instance. This exoplanet, located over 1,000 light-years away, is in the habitable zone of its star, Kepler 442. It's slightly larger than Earth, and scientists believe it has a 60% chance of being rocky, making it another promising candidate for future human habitation. Of course, these are just two examples in a vast cosmic sea of possibilities. There are likely millions, if not billions, of other planets within the habitable zones of their stars, waiting for us to discover them. This isn't just about survival, it's about exploration, about pushing the boundaries of what we know and where we can go. The death of our sun will mark the end of an era, but it could also herald the dawn of a new one, a time of exploration and discovery, of new homes and new horizons. Humanity's story doesn't have to end with the sun. The universe is vast, and we are but a small part of it. New worlds teeming with potential waiting for us to venture forth. Yet why limit ourselves to our own galactic backyard? There exists a vast universe beyond our Milky Way, brimming with galaxies, each presenting opportunities for new homes, new worlds, new beginnings. One such galaxy that piques our interest is Andromeda. It's our closest spiral galaxy, a mere 2.5 million light-years away. Now that might seem like an astronomical distance, and indeed it is. But in the grand scale of the cosmos, it's practically our next-door neighbour. Andromeda, with its trillion stars, holds promise for untold numbers of habitable planets. The sheer size and proximity of this galaxy make it a prime candidate for future exploration and potential habitation. Just imagine millions of stars, each potentially hosting planets that could be teeming with life or waiting for us to bring it. But let's not get ahead of ourselves. The journey to Andromeda, even at the speed of light, would take millions of years. We would need to develop technology far beyond our current capabilities to make such a journey feasible. The challenges are immense, but so too are the rewards. The thought of colonizing a new galaxy, of starting anew amidst the stars, is a tantalizing prospect. It's a leap into the great unknown, a step beyond our current understanding and capabilities. But isn't that the essence of exploration? The thrill of venturing into uncharted territories, of pushing the boundaries of human knowledge and experience, is what drives us forward. It's what has driven us since the dawn of our species, and it's what will continue to drive us into the future. We have a long way to go before we can seriously consider such a journey. There are countless technical, logistical, and ethical challenges to overcome. But the idea of reaching out beyond our own galaxy, of setting foot on a planet in another galaxy, is awe-inspiring. And so we look to the stars, to the galaxies beyond our own, with hope and anticipation. We stand on the precipice of a new era of exploration, of a journey into the great unknown. Boundless galaxies, each a new frontier for humanity to explore. However, all of this begs the question, do we have enough time? This isn't a query of mere curiosity, it's a question of survival. It's a question of our very existence. Time, after all, is the most precious commodity we have. And when it comes to escaping the fiery demise of our sun, it's the one thing we may not have enough of. The challenges of space travel are manifold. It's not just about building a ship that can withstand the rigors of the cosmic void. It's about creating a vessel capable of carrying the essence of humanity, our culture, our knowledge, our hopes and dreams, across the vast expanse of the universe. It's about devising a craft so advanced, so robust, it can sustain the lives of generations who will be born, live and die within its confines, all while journeying towards a distant, hopeful speck of light. The distance between stars is mind-boggling. Even at the speed of light, it would take us more than 4 years to reach our nearest stellar neighbour, Proxima Centauri. But we are far from achieving such speeds. Even with the most optimistic projections of current propulsion technology, it would take us tens of thousands of years to reach even the closest habitable exoplanet. This is where technological innovation comes into play. To make this leap, we'll need advances in propulsion, in life support systems, in artificial intelligence, and in countless other fields. The task is daunting but not impossible. After all, we've proven our capacity for innovation time and again. Yet the clock is ticking. The sun, our life-giving star, is on a countdown. We have about 5 billion years before it swells into a red giant engulfing our solar system. 5 billion years may seem like an eternity, but in cosmic terms it's a mere blink. So as we gaze upon the stars, we must ask ourselves, are we ready to make the leap?